Conductance of electrolytic solutions. Conductance of electrolytic solution. Based on conductivity, materials are classified one, conductors, second, semiconductors, third, superconductors, fourth, insulators. Now, each term we'll discuss now. First one, conductors. Conductors, the substance or material, the material which allows current or electricity through it is called conductors. These are two types. One is metallic or electronic conductors. Example, metals. In that metal example is silver, copper, gold and sodium, like this, in which based on their conductivity values, the highest conductivity is silver, then copper, then gold, last sodium, and some alloys also. For example, bronze, brass, etc. Alloys also act as a conductors. Some non-metals, example, graphite, act as a conductor. Next, carbon black, that also act as a conductor. Some polymers, not all polymers, only some polymers, only oriented polymers. Oriented polymers are good conductors. Example, polypyrrole, polyaniline, polythiophene. Next, their conductivity depends on electronic or metal conductor conductivity depends on one, nature and structure of metal. Second one, number of valency electrons. Third one, temperature. This is important. Temperature increases conductivity decreases. And fourth one, density of metal. Same, density increases, conductivity decreases. This is a conductivity depends on the some factors. Next, electrolytic conductors. The solution which allows current through it, that is called electrolytic conductor. Example, sodium chloride aqueous solution, potassium chloride aqueous solution, sodium sulfate aqueous solution, HCl aqueous solution. In this electrolytic conductor we have strong electrolytes. Strong electrolytes are completely ionized. Example, strong acids, strong bases, and salts. Sparingly soluble salts are not strong electrolytes. Then now weak electrolyte. Weak electrolyte example, weak acids, weak base, and sparingly soluble salts. These are the example for electrolytic conductors. Their conductivity depends on one, nature of electrolyte. One is strong electrolyte, another is weak electrolyte. Strong electrolytes has a high conductivity, weak electrolyte has a low conductivity because strong electrolyte completely ionize. High conductivity denoted with a K. So this is low conductivity. Second one, size and solvation of ion after ionization in aqueous solution. Generally, lithium plus sodium plus potassium plus rubidium plus cesium plus in gaseous form, which is a larger size. This is the larger size, cesium plus lithium plus smaller. But in aqueous solution, the size of ion is reverse. Lithium plus aqueous is greater than sodium plus potassium plus rubidium plus cesium plus. Therefore, conductivity order, smaller ion fastly move. Therefore, lithium plus aqueous is lower conductivity than the sodium plus aqueous, potassium plus aqueous, rubidium plus aqueous, and cesium plus aqueous. Reason in aqueous solution solvation increases for smaller ion, that's why that become larger size. So this lithium ion become the larger size, cesium ion become the smaller size because less solvation here, less solvated. Here more solvated, therefore this is larger size, less moving, smaller size, easy to move. That's why conductivity of cesium is greater than the rubidium, potassium, sodium and lithium. Similarly, anion F minus, Cl minus, Br minus, I minus in gaseous form, then which is larger size, I minus, then the Br minus, then Cl minus, F minus. But in aqueous solution, F minus aqueous is larger than Cl minus aqueous, than the Br minus aqueous, then I minus aqueous. Therefore, their conductivity order, this is size related. Now, conductivity order is F minus aqueous is less than the Cl minus aqueous less than the Br minus aqueous less than I minus aqueous, because this is smaller after solvation, this is larger after solvation. This is about the conductivity. Now, what is the difference between a metallic conductor and electrolytic conductor? This is metallic, this is electrolytic conductor. Now, this is a difference I will write. Electron, it means charge carrier. Charge carrier is electron. Here, charge carrier is ions, that is maybe positive or negatively charged. Next, no change of matter, no change of matter, as it is metal mean metal only. So chemical electrolysis takes place, electrolysis takes place here, therefore change of matter takes place. Now mass remain same. Here mass changes. Resistance is due to kernel. Kernel mean what is that? Nucleus and inner core electrons. Here resistance is due to force of attraction. FOA mean force of attraction and viscosity. This is the difference between metallic conductor and electrolytic conductors. Next, second type is semiconductors. Semiconductors meaning what is that? The material which has conductivity range that is 10 power minus 6 to 10 power 4 ohm inverse meter inverse, or resistivity range 1 to 10 power 6 ohm meter. Such substances are called semiconductors. Example, pure silicon and germanium and copper oxide. According to conductivity value in the textbook given, germanium is a good semiconductor than the silicon than the copper oxide. This is conductivity order. And doped with third A group and fifth A group elements to the germanium or silicon, we will get third group respect to p type, and fifth group respect to n type semiconductor. Next, superconductors. Superconductors has very high conductivity or zero resistivity. Such, such substances are called superconductors. Example, some metals and their alloys. Superconductors are two types. Superconductors are two types. One is low temperature superconductor. Second one is high temperature superconductors. Example for low temperature, that is 0 to 15 Kelvin temperature. These are called metals and their alloys. High temperature superconductors are ceramic, material, and mixed metal oxide. These are the example for high temperature superconductor, nearly 150 Kelvin temperature around. Next, insulators. Insulators meaning what is it? The material which has conductivity range 10 power minus 10, 20 to 10 power minus 10 ohm inverse meter inverse, which mean do not allow current through it. Such substances are called insulators, or also known as a non-conductors. If it is solution, then it is called non-electrolyte. Example for this insulator: diamond, glass, some ceramic, plastic, rubber, glucose solution for non-electrolyte. Next, urea solution. These are the example for insulators. Now, if you take, this is considered as conduction band, and this is valency band. This gap, this is called energy gap, EG, energy gap. If it is high, then this is called insulator. Little less, then this is less energy gap, then this is called semiconductor. Energy gap is very less, then that is called conductor. Very less is called superconductors. So this energy gap order is conductor is very less, then semi conductor little greater, then insulator.